Hello, everyone. Welcome to this week's Bounty episode of the Days Hero podcast. I'm Spectre. With me is Z. Happy Easter to those who, celebrate Easter today. And today we have some topics including an analysis of CAN bus injection being used to steal cars, a Pre-Auth RCE in Pentaho business analytics server, and more. First, though, we'll lead off with a HackerOne report on a bug reported to Elastic in Synthetics Recorder for recording interactions in a browser window. So Z, I'll let you get into this one.
Yeah, and this not too crazy of a bug, but I did think it was a little bit fun because it's at its core it's in code generation, so it is somewhat privileged off. Like being able to access or run or being the person recording these synthetic tests, it's a bit of an ask for sure, but I still kind of like the bug. So what Synthetics Recorder is doing is it's creating basically, or the idea is to use it to create these synthetic tests. Just to automate the browser to do whatever, like UI testing or whatever you're kind of doing with that. So you'll actually go in there, you'll record a browser session of yourself doing whatever you want to test, and it will generate code or JavaScript code automatically for you that takes advantage of the Playwright library, calls in that, does whatever. And it's just generating all this code for you based off of what you did in that recorded session. And so in doing that, one of the things it'll generate is on a page navigation, it'll generate this wait for navigation call, which is basically just, wait for the end of a navigation. Makes sense. And what they include in the generated code is this comment saying URL equals, example.com or whatever you're actually trying to go to, which makes sense, makes it a bit more readable because you don't have the actual URL it's waiting on in there. You are just waiting for like the navigation event to happen. I'm going to pull up the code here for it also. You'll notice that in this code, it's got page alias, wait for navigation. In this kind in the formatter, so it's adding this code to be printed. It's not calling this exactly directly. Generates the comment here and it calls quote whatever the URL it's waiting for, and that quote is supposed to escape all of the quotes. Again, makes sense. You're wanting to escape things. It does that. The problem is this isn't a quote. I mean, technically, yes, there is a quote inside of this URL. You'll notice it kind of creates it like a JavaScript object. So there is technically a quote, but it doesn't matter. Like, it's not about breaking out the quotes, it's a breaking out the comments. So what you can do here is if you basically with the specially crafted URL, if you visit, you can basically include the end comment and then get JavaScript injection and inject whatever JavaScript you want to run from there. So it's kind of a fun bug. It's kind of cool to see it in the code generation. It does feel rather privileged off to me, but it does depend on how people are using Synthetics Recorder on a whole. They did get a nearly $5,000 bounty out of this because it is ultimately resulting in code execution. I'm also not super familiar with Synthetics Recorder, so perhaps the use case is a little bit more open than I would expect it to be, but it does, my understanding is kind of indicating that, it is a bit privileged off, but still kind of a fun bug to see. And just a reminder about how context matters when it comes to escaping. You can't use the quote escaper when you're in the middle of a comment. That's just not the right context, and you have to be aware of where you're putting the data in order to escape. There's no generic, I'm just going to escape everything.
Something else I thought was kind of interesting is they point out for actually exploiting this that you could take advantage of this in the test functionality of the recorder, but it's also somewhat limited because the require function that they use in their POC isn't available, saying that the maximum impact is when the user saves a recorded session as a project and then executes that in the synthetic runner. So it seems depending on how the recorded session is ran, is also going to play a part in like how exploitable this is. Which I just thought was kind of interesting. It seems weird that like it's supported in this one area but not in another. The require functionality, that is.
Well, that's really just, is it running in a browser or is it running in Node? Node has requiring, your browser sense. Doesn't.
Yeah, okay, fair enough.
Well, okay, so I think your browser can have it, but then you have to be loading it as a module.
It's a bit more complex, yeah.
Well, it's a different way of writing the code, so it's generally not being written that way. If you're running in a browser, so that context difference does make sense, and that's just the way of kind of getting, because in a sense, require would be similar to doing a like script source and giving it whatever file you actually want to include. It's kind of doing that sort of functionality. So that's how you're able to on Node get access exec, but in other contexts, you don't necessarily even have child processes that you can go and start.
Fair enough. Yeah, that makes sense. So yeah, it's a little. There's a lot of context that matters when it comes to this vulnerability, but still, like you said, it was a pretty high paying bounty. So, and it's kind of a cool issue, and it's a good demonstration of the context mattering when you're doing escaping as well.
Yeah, it's a fun issue. I mean, we don't see a lot of code gen, so and that is also just an interesting when you see the code generation function. Like it isn't common, but it's really easy to make mistakes there that do lead to code execution because it's creating code.
Yeah, and that's never super straightforward to do in a secure way. So
Yeah, like
yeah.
there's a lot that can go wrong.
All right, so up next from Aura Research, we have Pentaonage, which is multiple vulnerabilities in Pentaho Business Analytics Server, which is like a data analytics platform for enterprise written in Java. 8 vulnerabilities were found, though only a few of which were detailed in the blog post. The first of which they go into is a server-side template injection in the LDAP API endpoint.
Yeah, before you jump into it, I just want to call out they have a really cool design on this site, but it also makes my whole browser just lag as I scroll here. You can see it just inching along as I try and scroll on this thing when it does the
Oh,
blur.
interesting. Yeah, I don't have any lag on my end, but I can kind of see it on the stream.
Oh yeah, no, it's really hit my browser. Maybe it is just my Chrome for some reason, but I thought it was just because of the kind of background blur that they try and do,
Could be.
creating issues. Yeah. Anyway,
Yeah.
that's completely unrelated to the vulnerability.
But yeah, so this first vulnerability they go into, they talk about the LDAP API endpoint for configuring and testing LDAP. So to facilitate this configuration, they have this LDAP config, LDAP tree node children endpoint, which will take a URL parameter that's passed straight into the properties file, which includes some other things like the thime leaf templates, which can execute class methods and such. So by simply passing that method call like into the properties file, the template will get parsed, and you can pop Notepad in the case of what they're demonstrating here, whatever else you want to run. Kind of a meme issue, but it does also require admin access to configure LDAP, and so it should be a pretty high bar to clear to access it. Except there is also another bug that can be chained with this, which is the second one, and it's an auth bypass due to allowing unauthenticated requests to access any endpoint ending in require.js. In most situations, this isn't like a super big problem because adding require.js into the URL is going to break it. Except in one notable case. Of course, it's that same LDAP endpoint we just talked about.
Okay,
In
so
that case,
just adding require.js. Actually, like you could do that in a lot of cases. Question mark require.js. The key thing here is that it's not just having that in the URL that's needed. It needs to be the file that's being accessed and with
sorry, yeah,
require.js.
yeah, it has to match the regex for that, and it has to be the file. Yeah.
Yeah, and that's actually I do want to call this out. Like it is a pattern I've seen a number of times where I mean, kind of with a lot of Java applications, you'll see kind of relying on those external XML files or not. Well, I guess it's not really external, but I feel like it's the wrong place to be doing any sort of authorization checks. One, doing auth with regex just feels like a bad idea. I get the concept where it's like all my paths that are privileged off are going to be in this path, so we just use a so we just use the regex, so that's faster than doing like a full auth check, which is fair, like fair idea, but I think auth belongs with the either with the handler or I mean you can make an argument to also kind of do it a little bit more centralized or that always calls out make sure it calls into an auth specific handler like with the handler, sorry. um doing it as like this XML one just feels like it could break so easily. As an application updates, you always have to remember to go and make sure you keep your paths in line with what your regex is doing and that your regex is right, versus having it, I guess, a bit more intuitively connected to the actual module. So it's something to keep an eye out for. Not necessarily because it's going to create issues, but it's really easy and really fragile.
Yeah, I mean, a fair amount of the issues that we cover are based around like bad regexing or like this style of
Using
authentication.
regex seems like a security issue too.
Yeah, like that's almost its own problem. So yeah, in this particular like LDAP endpoint, that file is just like the require.js is just ignored, and so it lets you get access to the LDAP config endpoint to exploit the previous bug. There were also a few other issues, including RCE via HyperSQL DB, which has tight Java integration. I'm not super familiar with it, but apparently it allows calling like Java gadgets and such, which you could use to call like the write bytes to file name from the file class to write data to a file, which you can use to write shellcode, which will eventually get ran for a query through like the report designer or whatever. Along the same lines, there was also a Groovy scripting RCE vector, which was just provided this functionality when adding a Java database connectivity source. So, yeah, I mean, the latter two issues were mostly just taking advantage of the database functionality for RCE, but the first two chained together really nicely and were kind of the more important reportings in the post, I think.
Yeah, the first two bugs are kind of neat or kind of fun, but the last two, it really just feels like a design decision. Like, yes, you can do that because that's a functionality they want to support for their users. Feels like this is going to be a pretty privileged off application to begin with. Obviously, there's the auth bypass, so you can get around that, but for the RCs, it's likely that that is just like, yeah. I guess I should have taken a look here. What's the CV for that? Um, I'm just
Yeah, sorry, I'm
wondering
just
if
opening it
they
as well.
talked about the patching for it. That is the wrong paste.
Yeah, so the way the CVE is worded was prior versions installed with the sample HSQLDB data source configured with stored procedures enabled. So
Okay,
I
so
guess
they're
it's
just
this.
disabling, yeah, the stored procedures, and
Yeah,
then if you don't support that, you can't get access easily to running your own custom Java gadgets. Fair enough, that makes sense.
yeah. So yeah, I really like the way those first two issues chain together. Like I said, I'm not too familiar like with this style of product or like the database being used, but yeah, it was pretty easy to follow along, and yeah, some cool issues there.
Yeah, the ordering does feel a little bit weird to me, and this is kind of a nitpick, and I get why they did it this way, so it's not even that much of an issue. But starting with the SSTI and then the require bypass versus, exploit flow would be require bypass, then server side template injection. That said, whatever. It's like they covered it that way because that is kind of the more interesting way to cover it. But yeah.
All right, so up next we have a story of both a unlucky and lucky person, depending on how you look at it, from the automotive security space. So Ian Tabor and Ken Tyndall did an analysis after Tabor's car was tampered with and eventually was stolen. And what was notable was before it was stolen, he posts these pictures, and I'll bring them up for those who can see. For those who are just listening, the car is like pretty beat up, and the front end has like the bumper clearly tampered with, and the headlights. And after that, the car ended up getting stolen. And after looking at the diagnostic codes that were reported through like the My Toyota or My T app, they eventually determined something really screwy was going on with the CAN bus, because there were a lot of errors getting reported for, of course, the lighting control where the headlights were tampered with, but also the front cameras, the hybrid engine control, a bunch of other devices that didn't really make sense.
It's
Um,
probably worth mentioning what the CAN bus is for people listening. I know we've talked about some issues there on the binary podcast, but I'm not sure for the bounty one.
Yeah, we haven't really covered it on Bounty, so that's a fair shout. you can kind of think of the CAN bus as like a network, or like the central bus where all devices kind of talk to each other. So like the headlights will be on the CAN bus. You'll also have um, like the key, like ignition device on the CAN bus. Let me just see if I can bring it up here.
Yeah,
Yeah,
like
so
each
they have a good diagram that demonstrates it here for those that are watching.
yeah, like you can have technically multiple buses. These are all connected through the gateway, but you'll have the various electronic units in the car connected there sending messages around. But so like it makes sense that things might want to communicate a little bit. One button, tells the air conditioner to change or something, you send a message to do that. Makes sense. So when you think about it, that's just how the car does it. But if you've never looked at automotive security, you may not be familiar with that at all. So, I mean, it's not all that complicated, but I still figured it was worth mentioning how or what it was.
Yeah, a lot of the times we've covered it in the past where when we were covering the white papers that were talking about like messing with the camera primarily, or trying to, hijack the CAN bus through like the entertainment system or things like that. It's been a little while since we've covered it, but
Yeah, and that actually kind of ties in here. I mentioned kind of having the gateway in here. So usually you'll have things kind of sectioned off a little bit. You'll notice in here we have like the radar and parking assist are over in one section. And they're all connected to the gateway, but not directly to anything else. And engine controls off on its own. Um, so like your entertainment unit, might be able to send messages, but they'd send to the gateway, which then get routed where it should go. They don't have direct access to message any of these or a lot of the other services. They'll only have a small segment of it actually accessible. So other vulnerabilities we've talked about been like navigating between the I guess different components so that you could do something more dangerous from one that's sectioned off.
yeah. So yeah, like I was getting into, they eventually determined the car was stolen using a device that would inject into the CAN bus. And that's because it seems many vehicles consider devices on the CAN bus to be secure and thus trusted. So if a thief can wire up a malicious device that can talk to it through something like the headlights, um, they could potentially hijack that CAN bus and inject messages such as the smart key being valid. So on the top bus that they talk about there, you can see like the headlights are on the same bus as the smart key. Um, and yeah, it's not really designed to consider messages on that bus could be untrusted. They go through some of the intricate details of how that works because they did have to do some tricks beyond just injecting the messages. Like they had to prevent conflicts with smart key signals from valid key controllers, which basically just involves blocking other controllers on the bus from talking, which is actually what sparked those diagnostic codes, I believe. So yeah, they go into some of the detail there. I'm going to skip over it mostly because it comes down to a fundamental design issue of just allowing and trusting messages on the CAN bus that can be injected. Um, yeah, just trusting them outright. Now, to be fair, it is a little bit vehicle specific on how impactful this is. I believe in this case it was a Rav4, and they were able to access the CAN bus pretty easily through the headlights. I think they mentioned though that like depending on the vehicle, it might be like easier or harder to be able to get access into the CAN bus. But generally, ECUs and stuff on the car are going to be in the same sorts of locations on most models. From what I understand, like I'm not in the automotive space, but from what my limited understanding of cars are generally going to be in the similar areas. So yeah, especially on the more like fully featured cars, it's probably like even easier to take advantage of this type of issue. And yeah, like people just sell devices to do this kind of thing on the black market for, thousands of euros or whatever. You can actually build it for like way cheaper because it just basically involves a can, like a chip that can talk to the CAN bus and, like a board to facilitate that. It's nothing super crazy. Um, the way that they mention would be, you know, it's kind of difficult to mitigate this on existing models because, uh, you know, the models that are out there, like the code is there, the CAN bus design, it's kind of a fundamental design flaw issue. The way to address it would be to design it better, basically. Um, to have like more authentication on that bus, potentially using like crypto or, something like that to make it a bit more difficult to be able to just send whatever you want on the bus and have it trusted.
Yeah, I
But
mean, some sort of
yeah.
message signing. I don't. So part of the challenge here is like these are like small embedded devices effectively. You don't have a lot of, CPU to run with, but yeah, like this sort of injection attack is either you'd want to find a way to authenticate messages, so like everything has maybe a secret key that's shared, so you just do like a hash with do like a HMAC. Could go all like pub or like all like proper crypto on it.
Yeah. Though it's worth noting, like, I think they call this out in their post too. You would have to be careful with how you do that because you would basically have to make each ECU have a different key for that. Because if you just had like a global key, then an attacker would just have to buy one model of the car, just obtain one ECU, decap it or whatever to get the key, and then it's broken for all models. It is like
I was thinking it would register like itself with whatever key, but then you need to protect the registration. Yeah, I mean it isn't necessarily the easiest thing. Although Belika is mentioning that BMW uses RSA to do config changes, so
that makes sense.
Perhaps there's just computers are getting a bit better, can fit that on and actually do like the. I mean, I guess RSA isn't too bad or like too heavy. Although
I don't think it's too expensive.
Well, I'm saying that, but like AES is definitely a lot cheaper than RSA. So
yeah, but a lot of like crypto chips can do like RSA and AES, like they're kind of bundled together. So I would imagine they're fairly comparable when it comes to how expensive they are on the chips for running it.
Yeah, I mean, ultimately, like as a vulnerability, I'm not sure too many of you are going to be hunting for this sort of issue. But I saw this post over the weekend, and I just thought it was kind of interesting to see a bit of that detail and how people were practically going around, abusing this to steal vehicles. Like I thought it was interesting, but fundamentally, this is just there's no auth between messages. Like it's a very simple issue fundamentally. Also, Blika mentioned in chat, for a CAN bus is controller area network bus. We didn't mention that while talking about the CAN bus, so that's what it stands for.
Yeah. For me, the most interesting part was just like the story around it. Like how I opened the topic, kind of lucky in the sense that, I mean, I feel bad even saying it that way, but like lucky because it did it for like a research opportunity and got them to look into it, but unlucky because nobody really likes having their car stolen. It's not it's not a fun process to deal with. I know some people who have had it happen to them. It sucks. So yeah, I guess there was a tiny bit of a saving grace in the form of a research opportunity, but yeah, it's a fun story and for everyone except the person who it happened to. And also there's some cool technical details in here. If you're more interested in like the automotive space and how the CAN bus works, there is some excellent technical details in here that I think you should check out. It's a bit of a longer post, but it's pretty understandable even if you're not in the automotive space. So
yeah, I thought it was an interesting post. I mean, it does go pretty deep into like the signals aspect, which I kind of just glossed over.
Yeah. So our last post is on a Privesk in AWS Elastic Kubernetes, and Z, I'll let you take this one away.
Yeah, so this is specifically on like AWS running the Kubernetes service. And it's purely a privilege escalation. So this is assuming that you were already kind of, maybe RCE on an application running in a pod or whatever. You've already got some level of access. This is now your escalation from being privileged off to getting cluster admin. And the first step of this is fairly well-known thing. If you're on a pod, you can hit the AWS metadata service and get the ECS instance metadata key. So you make that request, it has all the information there, and you can get like the all the information about like the current ECS user. You can assume that and whatever privileges come along with it. And then there's prior work that kind of showed how you could use from there, go like EC2 delete network interfaces. With that access or with that user, you would be able to make that call and kind of have some damage done there by deleting a network interface and denial of service. What they decided to look at was, well, can you go further than that and actually do something a bit more useful? And so what they noticed here was that you could take that same EC2 information that you got out of the metadata service, and you can then return that back in towards the EKS or the Kubernetes deployment. You can then provide it that key and exchange that for a token for EKS, and that token would be a system node token. So basically, it would think that you're the container node. You would have access to all the things that the node could do, not just the pod that you're actually that you maybe escaped into. Now you escalate up, you've got the privileges of the node itself. So the node can do things like see whatever's running or whatever's bound to its node. It can get information about those pods, definitions. And what's important here is, and kind of where a bit of luck comes into play with actually abusing this, is that if you're on the node and you have the node privileges, you could access the tokens for all of the pods on your node. So if you have a highly privileged pod that has been randomly assigned to run on your node, you can then take its key. So if it is a cluster admin, you would be able to take that key and exchange that to now have cluster admin on the whole node, which I feel like we've talked about a very similar escalation before, where once you're on the pod, once you have the pod node, like just using some lock to get onto or to get to cluster admin based off of the randomized mapping of things, because most people, when they set up Kubernetes, don't actually set up so all the privileged applications run in one area or run on just one node or one set of nodes, and kind of separating them like that. You should do that. Like, that is a good defense in depth step, but a lot of things don't do that. So when it gets randomly assigned, you can basically take over to cluster admin. I figured it was worth calling this out as an escalation method if you're not aware of doing that exchange back and forth, especially going back from the EC2. I think I might have been saying ECS earlier. I apologize if I was. From the EC2 machine, changing the token back for a Kubernetes token. I thought that was kind of interesting to see that you could go that route. At its core, like, the root issue here does feel like it's just the fact that you're letting the pods access the metadata information. Like, that is kind of the first escalation, probably where it should stop. The fact that the node itself, because Kubernetes thinks it's dealing with the node, the fact that the node can get a token for the node, that makes sense that it can do that. They do also go into kind of setting up a backdoor here that takes advantage over how it validates users, and it doesn't actually check any of the privileges of the user. It kind of maintains its own mapping. So even though AWS IAM might have a very low privileged user, they can be added as like a very high privilege in Kubernetes. But I'll leave that for you to read if you want to look that. It basically just deals with the fact that Kubernetes maintains its own auth list and privileges associated with each account. So it doesn't care what IAM says about it. I don't know, thought it was interesting and just kind of a trick to be worth knowing about in case you find yourself, looking to escalate or break out.
Yeah, similar to some of the other topics we've covered, this seems like sort of a fundamental design issue that was just, I don't know, maybe a little lazy, where it was just like, just allow pods to, get their own metadata, like they state in the remediation steps. So yeah, it seems like actually fixing this isn't super easy. They say like addressing this is not straightforward and would need a lot of planning. They do mention some, I guess, hack fixes that you could do. Like you can block pods from reaching the metadata by changing the put response hop limit. So there is some stuff you can do there, but it seems like a kind of like I said, a design flaw that just, it wasn't really designed in a way that's super with security at the front of your mind. So
Yeah, I mean, it is a very fundamental issue, because after that first exchange from the node, like getting that node metadata, after that, like, the rest of it is just normal design. Like, there's nothing really wrong with that. You can, I guess, make a complaint about like being able to do the EC2 token to the EKS token. to the Kubernetes token. Like, you could maybe make a claim about that, and they do call it out here as one of the root causes of it is being able to do that. That feels kind of okay to me because the node, like that EC2 instance, is the system node. It makes sense to have that exchange in my mind, at least. The argument can be made,
I
but
kind of agree.
Yeah, that first step is just. I think the other thing here is, going defense in depth, not allowing every node to run every sort of pod. If you have a privileged pod, and this does depend on having a privileged pod. Well, I think you're going to have the one running by default. So you're kind of at a loss there, but separating them out so your privileged pods run in one location would be a good defensive mechanism here, but yeah, I mean, it's definitely a challenge. And it does rely on you having code execution already. Like, you do have to have a pretty serious compromise already. There are likely going to be other ways of escalating too. This is just an easy one if you're on AWS.
All right, so I believe that's all the topics we have for this week. Z, unless you have any last minute thoughts or shoutouts, we'll go ahead and wrap up the show.
And no shoutouts this week.
All right, so as always, thanks everyone who tuned in. Recent episodes can be found on Twitch, and all of them are up on YouTube, Spotify, Apple Podcasts, more links on Anchor. Discord and Twitter links are down below or in the chat. And with that said, we'll be back tomorrow at 7 p.m. Eastern, 4 p.m. Pacific for binary topics, which is also where we cover this about the vuln solution. And we'll see you then.